Well, hello there. Good morning from Vienna and Austria, but wherever you're tuning in from in the world, hope you're having just the best morning, the best afternoon, the best evening. Hope it's not too late there. Remember, all of this is recorded on YouTube. And welcome to the sixth and final week of the free JavaScript Bootcamp that we are doing in collaboration with Class Central. Thank you, Class Central, and using the materials from FreeCodeCamp. Thank you, FreeCodeCamp. It's just great to see you all. Before I start looking at where people are tuning in from, never mind. We got people tuning in from New Zealand. Hello, Alan. Good to see you. Where else are folks tuning in from? From Sydney, Australia. Hey, Sil. From Germany. Hey, to me, Phil. I love seeing this. Brett. Hey, Brett, tuning in from the US. From Nigeria. From Ginsendorf. That's not too far from here. Love it. From Melbourne. Hey, good morning. From South Africa. My goodness. It's just wonderful to see you all here. And thank you for sticking around for all these weeks while we, learn some JavaScript. Let me quickly put up some links. First of all, if you're tuning in for the first time and you're like, what the heck is going on? Let me tell you. Hi, my name's Ramon. We're teaching a free JavaScript bootcamp just to learn the fundamentals and get us ready for our free FreeCodeCamp certification in JavaScript algorithms and data structures. Let's get some links. See, if you want to sign up, you totally can. Classcentral.com, you'll find the bootcamps there. You'll also find one from my friend Jess, who's such a good teacher, and she's teaching web development, HTML and CSS. I would recommend not doing both at the same time, just because it's a lot of work. You totally can, but it is a lot of work. If you want to get the materials and look at the certification from FreeCodeCamp, go to freecodecamp.org. You'll find everything you need there. If you get stuck along the way, be sure to ask questions at the forum, group.classcentral.com. Folks are always there. Thank you so much to everyone who's taking the time to answer questions and help others out. And let's see what else we got. Yes, of course, we have a Discord channel. If you want to chat more synchronously, you can totally do that there. And well, given that we're all learning together, I just want to remind you, we do have a code of conduct that we expect learners to abide by. If you have any concerns you would like to address or send our way, please do so by emailing bootcamp@class-central.com. Yeah. Oh, we got a couple more folks tuning in. I hope it's okay if I go ahead and show where from. We got folks from Zambia, from the UK, from Poland, from Argentina, from India, from South Africa, from Ghana. Love it. Love it. Love it. Love it. Zavarko's asking, can I get another invite for the Discord? I had to reinstall it and lost my previous account. Kiki, if you don't mind, could you throw up a link to the invite, please? Alrighty, let's kick it right off and see where we'll be going next. Now, we've got 3 more lessons that we're going to be doing together. The first, as I share my screen here, you will see is functional programming. But I just want to take a moment to explore what we'll be doing tomorrow and the day after. So today we'll be doing functional programming. Tomorrow we'll be doing our last set of lessons, which is the intermediate algorithm scripting section. And then on Wednesday, finally, the last one will be the cash register project. Once we're done with this, you will get your FreeCodeCamp certification. So let's dive right in. Today we'll be doing functional programming, which you might have heard of before. It did come up a couple times during this bootcamp. And what it is essentially a different way to say more imperative programming. Functional programming really sort of is a mindset of dividing the way we work, the way we code, into smaller functions, which really operate on one big premise. No side effects. We'll see that in a moment. And it's kind of like, whenever I think of functions in functional programming, I like to think of them as boxes that, aside from coding them, when I call them, I don't see on the inside. I'm just like, what does this function do? For example, it takes a string and gives me an array of separated words, right? I put an input, I get an output. none of the things that are around that function get affected. Again, we'll see what that means shortly. So let's dive right in to learn a little bit about theory of functional programming. So on the left here, you'll see the instructions. On the right, you will see some code. And well, let's just hop right in and see what we're doing with. And cool. See, even FreeCodeCamp agrees with me. Functions are simple, isolated functions without any side effects outside of the function scope. You put in an input, that input gets processed, and it returns an output. And let's look at these three core tenets that we have. First is isolated functions. There's no dependence on the state of the program, which includes global variables that are subject to change. That means functions should not depend on global variables. A function takes an input, processes it, gives us an output. Again, no dependence on global variables. Second, pure functions. The same input always gives the same output. That's interesting because if we depend on global variables, that's not necessarily true anymore. Again, we're going to see what that means. And three, functions with limited side effects. Any changes or mutations to the state of the program outside the function are carefully controlled. And this is really driving home what I've been trying to say here. A function exists in an isolated state where you put in an input, it processes it, and give us an output. But there's a little bit more to it as well. So let's take a look at our exercise. The members of FreeCodeCamp happen to love T. Same. In the code editor, the prepare T and get T functions are already defined for you. Call the getT function to get 40 cups of tea for the team and store them in the T for team FCC variable. So let's just carefully step through our code here on the right and see what this is all about. First, we have a function that returns a string representing a cup of green tea. So that's a const prepare T, which is an arrow function that returns the string get green tea. Next, given a function representing the T type and the number of cups needed, the following function returns an array of strings, each representing a cup of a specific type of tea. So let's see. It is a function that takes a number of cups as an argument. And here's what it does. Creates an array of teacups, loops from 1 to the number of cups, going up by 1 every step. And the teacup is determined by calling the prepare T function, which you remember is up here. We push that teacup to our array of result teacups, and then we return that array of result teacups. Before I solve the exercise, I'm just going to do my favorite. You all know it. You all love it. Some console logging. So we'll call the get T function. And let's say we want 5 cups of tea. So that gives us 5 green teas. Makes sense? Cool. Let's do what the exercise wants. Call the getT function to get 40 cups of tea for the team and store them in the T for team FCC variable. So get T 40. And I'm going to console log T for team FCC just to verify that I do indeed have, let's expand this, 40 cups of tea. So we're doing what the exercise wants. And some of you have been wondering, but Ramon, haven't you been talking about avoiding using global variables? Well, bear with me, folks, because we'll get there. Let's run our tests. And it passes. We pat ourselves on the back, pat, and we move on to the next exercise. So now, some of the FreeCodeCamp team are saying, well, some of us like green tea, but some of us like black tea. So the function getT has now been modified to take in a prepare T argument. This makes getT more flexible and gives the programmer more control when client requests change. Now let's look at some terminology here. This argument here, prepare T, is what's called a callback because prepare T is a function. We're passing in a function as an argument to a function. let me think about that again. So we have a function getT, and one of the arguments it takes is itself a function. This argument function is sometimes referred to as a callback. So if you hear me talk about callbacks, that's what we're talking about. And Functions that can be assigned to a variable passed into another function or returned from another function, just like any other normal value, are called first-class functions. So this prepare T callback is what's called a first-class function. In JavaScript, all functions are first-class functions. Now, if you remember from last week, we were storing a function in a variable. This is what's happening here as well. We're storing a function in prepare T. The functions that take functions as an argument are called higher order functions. So getT, because it takes a function as an argument, is called a higher order function. And the last piece of terminology we'll explore, when functions are passed into or returned from another function, then these functions which were passed in or returned can be called a lambda. Let's summarize. Prepare T, which is a function passed as an argument, is called a callback. The concept of it being a function that we can store in a variable makes it a first-class function. In JavaScript, all functions are first-class functions. This can also be called a lambda. You might see this in other programming languages as well. And finally, a function that takes a function as an argument is called a higher order function. Now, if I may recommend which one of these terminologies to focus on, it's callback. You're going to see callbacks a lot in JavaScript. So again, prepare T, which is a function that is passed as an argument, is called a callback. Let's take a look at what's going on here. We need to prepare 27 cups of green tea and 13 cups of black tea and store them in T for green team FCC and T for black team FCC variables respectively. Note that the getT function has been modified, so now it takes a function as the first argument. Note, the data is supplied as the last argument. We'll discuss this more in later set lessons. So let's go through our code again. We've got 3 functions now. First, there's the prepare green tea function that returns the string green tea. Then we've got the prepare black tea function that returns black tea as a string. Then we've got getT, which takes 2 arguments, a function, and a number of cups. This is going to look similar to the last one. So we've got our teacups array. We do our loop like we did last lesson. But now when we want to make a teacup, we are calling that argument function, that callback. We're calling that callback to say, hey, give me that cup of tea and let's push it into the teacup array. Then we return those teacups. So when we want to call getT, the first thing we want to pass is that function. Now, when we want to pass a function, like say, let's see, for the green tea, we want to call prepare green tea. Sorry, not call, pass. Prepare green tea. I'm just going to expand this a little bit so we have some more space. Now, notice something. When we're passing in a function as an argument, we are passing the pure function itself, not its return result, which means I am not putting in the brackets for this function. Putting in the brackets calls the function. Leaving out the brackets passes that function itself. Let's take a look. How much was it? 27 cups of green tea. And I'll tell you what I'm going to do. I'm going to console log. Are you all surprised that I'm going to console log? Prepare tea and num of cups. And this is what I want to be very careful about to really like drive home. The prepare tea argument is temporarily storing the function prepare green tea. So inside this variable, we've got the prepare green tea function, which in line 17, I then call. And num of cups is 27, which I passed in here. So the result of that, which we console log in line 28, is 27 cups of green tea. Let's do the same now for black tea. We'll do get tea. We'll pass in the callback prepare black tea. And how many cups was it? 13. 13. There we can see we passed it incorrectly. And now the second time that we call get tea, the console log is telling us, yes, prepare tea has the value of the function prepare black tea. I'm going to answer this question. Is this correct? Callbacks is another name for Lambda functions. Yeah, callbacks are very specific to JavaScript, I would say. You might see it in other programming languages too, but that's like you will definitely see callbacks as a name in Java in the context of JavaScript much more than you will see Lambda. And I think contextually they're pretty much the same. Yeah. No, wait, big difference. Lambdas are functions that are either passed in or as arguments or returned. Whereas callbacks are the functions that are passed into a function. Yeah. So callbacks passed in as arguments, Lambda passed in as arguments or returned, because you can return functions as well. We'll leave other questions for the, like, if I'm not answering your questions, don't worry, we're going to save them for the end. But to answer your question, Akachuku, is callback the same with recursion? No, because we're not storing that callback in a variable with recursion. We're just calling the same function. That's a good question. Cool. So let's run our tests. And it passed. Pat. We move on to the next one. Now here comes the big one. Functional programming. I'm going to read the whole thing because this is sort of a longer exercise. Functional programming is a good habit. It keeps your code easy to manage and saves you from sneaky bugs. But before we get there, let's look at imperative approach to programming to highlight where you may have issues. In English and many other languages, the imperative tense is used to give command, imperative. Similarly, an imperative style in programming is one that gives a computer a set of statements to perform a task. And most programming is imperative. We're giving a computer commands, and the computer executes those. Often the statements change the state of the program, like updating global variables. A classic example is writing a for loop that gives exact directions to iterate over the indices of an array. In contrast, functional programming is a form of declarative programming. You tell the computer what you want done by calling that specific method or function. JavaScript offers many predefined methods that handle common tasks, so you don't need to write out how the computer should perform them. For example, instead of using the for loop mentioned above, you could call the map method. We'll get to map in a bit, which handles the details of iterating over an array. This helps to avoid semantic errors like off by one errors that were covered in the debugging section. So consider this scenario. We're browsing the web in our browser and we want to keep track of the tabs we've opened. Let's try to model this using some simple object-oriented code. Some object orientation, nice. So a window object is made up of tabs, and you usually have more than one window open. The titles of each open site and each window object is held in an array. After working in the browser, opening new tabs, merging windows, and closing tabs, you want to print the tabs that are still open. Closed tabs are removed from the array, and new tabs, for simplicity, get added to the end of it. The code editor shows an implementation of this functionality with the functions for tab open, tab close, and join. The array tabs is part of the window object that stores the name of the open pages. Let's take a look before we get to the exercise. So we've defined a function, window, with tabs. Oh, this is a constructor. Nice. Remember from last time? So we got a function, a constructor function, that stores an array of tabs. Cool. In line 7, we define the function join on that window that, let's see, this.tabs equals this.tabs concat other window. So it takes a different window and concatenates that other window's tabs to our window's tabs. So say we have one window with 2 tabs and we have one window with 3 tabs. When we call join on this window, we add these tabs there. So we got 5 tabs. So far, so good. Then we've got on line 13, we define the tab open method, which opens a new tab. It pushes a new tab onto our array of tab with the title new tab. So far, so good. Then we've got close tab. And what we do, tab close, which takes an index. And what do? We splice everything from 0 to index. Then we splice everything from index 1 onwards, index plus 1 onwards. And then we just take those tabs from before and add to them the tabs after, meaning we're taking everything before, everything after that index, and putting them together, essentially removing the tab at that index. And don't worry, we're going to visualize this in a minute. Then we've got 3 browser windows. Let's expand this a little bit to see what we've got. We've got one window with Gmail, Inbox, Workmail, Docs, and FreeCodeCamp. We've got one window with which I'm guessing is Facebook, Gitter, Reddit, Twitter, and Medium. And we've got Netflix, YouTube, Vimeo, and Vine. It's a little older. Okay, so on the social window, we're calling open a new tab. Then we're calling close the tab at index 2, 0, 1, 2. We're going to close Reddit. Then we'll close the one at index 1, which is Gitter. We'll open another new tab, and then we'll console log those tabs. So let's see what we've got. We got at the end, once we're done, we've got a console log. We got Facebook, Gitter, Reddit. But these two should have been closed. Shouldn't they have? Huh. Then we got Twitter, Medium, and new tab, Netflix, YouTube, Gmail, Docs, FreeCodeCamp. Oh my goodness, join. Oh, I missed the joins. Let me walk through that again. I'm sorry, folks. I missed this join. So on the video window, we close the second tab, 0, 1, 2. We close Vimeo. And then we join that with social window. So we close Vimeo and then put Netflix, YouTube, and Vine at the end. So after Medium. Then on the work window, we close Inbox. And then we open a new tab. So let's take another look at this. So we should have closed Vimeo, and Vimeo is indeed missing from here. That's good. And we should have closed Inbox. But I get the feeling that Workmail is missing. And so is Docs. No, Workmail, Docs is indeed there. So something a little erroneous is going on here. Examine the code in the editor. It's using a method that has side effects on the program, causing incorrect behavior. The final list of open tabs stored in finaltabs.tabs should be FB, Gitter, Reddit, Twitter, Medium, new tab, Netflix, YouTube, Vine, Gmail, Workmail, Docs, FreeCodeCamp, new tab. But this list produced is slightly different. Let's take a look. FB, Gitter, Reddit, Twitter, Medium, new tab, Netflix, YouTube, and that's so far fine, but then Vine is missing. Then we go to Gmail, Workmail is missing, Docs, FreeCodeCamp, new tab. So it seems to be removing an extra one. Change the window prototype tab close so that it removes the correct tab. So let's take a look at tab close real quick. We'll start here again. Tabs before index. This.tabs.splice 0 to index. And then we do tabs after index, which is this.tabs.splice index plus 1. So I'll give you the long and short of it. The problem here is about side effects. And the side effect comes from the function splice. The side effect of splice is that not only does it give you everything from 0 to index, but if you remember, splice also modifies the original array. effectively removing those. Unlike splice, for example, unlike slice, for example, that creates a copy of that array. And to illustrate this, I'm going to take all of this code, all of it, all the code. Give me the code, my code. And we'll put this, again, thank you so much to Sil for showing us this, the JavaScript visualizer. And I'm just going to drop a link to that here in the chat. So there's our code. Let's visualize the execution. All right. So we start here, defining our window object. Just going to step to the next one. Defining functions. Cool. Defining another function. Then we define our 3 windows. Window, window, and window. It's a bit hard to see that's because I have to zoom in. But essentially, we've got our 3 window objects here. Right? There's the first one, there's the second one, and there's the third one. So far, so good. Now we're going to call tab open on the social window. We see here. So we push a new tab to that social window, and that should be done. Let's see what happened. Social window should now have a new tab. There it is. Fabulous. Then we're going to call join. But first we need to call close. Yeah. So now remember we're in the, which one are we calling here? The video window. Now let's take a look at what happens. Tabs after index is getting defined. Tabs before index is getting defined. Done. Let's scroll all the way down and see. So tabs before index are Netflix and YouTube. But look what happened to the original tabs. Now it's been modified. Eh? That's where the problem comes from. So tabs after index is saying, well, let's just grab everything at index plus 1. But index plus 1 is no longer correct because we've removed all of the original tabs before. So what really we should be doing is not starting from index plus 1, but rather starting from 1. Because we've already removed everything up until index. So we just want to get out Vine. Now that we've identified that problem, we can actually jump back to our code and change that. If I do this now, let's take a look at our array. FB, Gitter, Reddit, Twitter, Medium, new tab, Netflix, YouTube. There's Vine. Vine's back. I'm glad Vine's back. Sorry. Gmail, work mail, docs, FreeCodeCamp, new tab. Now that we're modifying the array and mitigating those side effects, let's run our tests. And there we go. Pat, pat. Folks, this one is a big, chunky exercise. I would recommend watch this video again and use that visualizing tool to go through it. Let's move on for now. Hey, yeah, so of course, we're not affiliated with FreeCodeCamp. We're using their materials, and they are an open source and nonprofit organization. So please, if you can, donate. But if you don't have the funds, don't worry about it. I'm donating myself, but on a different account. Yeah, so you can totally ask me later and come back later if you can and, donate a couple bucks. Still saying that would be still something with a side effect. Slice would be better here. And you're absolutely right, Sil. You can absolutely use something without a side effect. What I did was mitigate, as in to take away, sorry, not to take away, to manage that side effect. But you can absolutely do it with Slice. Okay, so let's just read this one real quick. If you haven't figured it out, the issue in the previous challenge was with the splice call. Unfortunately, splice changes the original array, so it's called on, so the second call to it used a modified array and gave unexpected results. So one of the core principles of functional programming is to not change things. Changes lead to bugs. It's easier to prevent bugs knowing that your functions don't change anything, including the function arguments or any global variable. Which is why we liked this is why we like const so much. So changing or altering things is called a mutation, and the outcome is called a side effect. And again, we want to reduce side effects as much as possible. A function ideally should be a pure function, meaning that it does not cause any side effects. So in our exercise, fill in the code for the function incrementer so that it returns the value of the global variable fixed value increased by 1. So let's see. We've got our global variable, fixed value is equals to 4, and this function wants to return fixed value increased by 1. Fixed value plus 1. So here's a question. Are we modifying things? Are we causing side effects? Side effects. Incrementer. If I call... can I not spell? Incrementor. There we go. There we go. Cool. Are we causing side effects? Calling incrementer returns 5. Have we modified fixed value? No, we haven't. So far, so good. But we're still interacting with the global variable, which is something in functional programming that we want to avoid. So that's what we're going to be looking at in the next exercise. Pat. Pass arguments to avoid external dependence in a function, which, as I said, there's still something missing from the last exercise, which good. We didn't alter the global variable, but the function would not work without the global variable. And remember, functions are supposed to be self-contained. You declare your dependencies explicitly. This means that if a function depends on a variable or object being present, then pass that variable or object directly into the function as an argument. For example, some of the benefits include the function is easier to test. You know exactly what input it takes, and it won't depend on anything else in your program. It really is self-contained, a box that we never look inside. This can give you more confidence when you alter, remove, or add new code. You would know that you can or cannot change, and you can see where the potential traps on. And here's the important part. The function would always produce the same output for the same set of inputs, no matter what part of the code executes it. And do you remember we talked about that in that first section? We put in an input, it processes it, and it gives us an output. Always the same effect, always the same output for the same input. So what we want to do here is update the incrementer function so it clearly declares its dependencies. Write the incrementer function so that it takes an argument and then returns a result after increasing the value by 1. So it will take a num plus plus, added an extra space, and return num. Let's console log that. Incrementer, and we're passing in the global variable fixed value. Now it gives us 5. Still good. Is fixed value still 4? Yes. So now this is more functional, because every time we call incrementer, no matter what happens to fixed value, if we give it the input of 4, it will always give us 5. Let's run our tests. So far, so good. Pat. I'm going to take a drink. So let's see. 2 things we've done so far. We avoid altering a variable or, excuse me, we avoid altering a variable or object. We create new variables and objects and return them if need be from a function. Second, we declare function parameters. Any computation inside a function depends only on the arguments passed to the function and not on any global object or variable. I like that they say adding one to a number is not very exciting, but we can apply these principles when working with arrays or more complex objects. So let's take a look at our code real quick. Primo Crip's asking, what drink do you usually take? This is just water. So we've got our global variable here, which is called book list. We've got 1, 2, 3, 4 books. 1, 2, 3, and 4. Cool. Now, we've got a function add, which takes a book name. It takes that global variable and pushes that book name to the book list, and then it returns the same book list. Okay. Then we've got another one called remove, which takes a book name, which gets the index of that book. If the book index is bigger than 0, remember, because if it's -1, it's not in the array. Oh God, goodness gracious me. We do splicing. We remove that book index. Remove everything. Oh yeah, we start removing here and we remove one object. We remove that book from the book list and we return the book list. Okay, then we return that book list. Let's see what the exercise is. Rewrite the code so the global array book list is not changed inside either function. The add function should add the given book name to the end of the array passed to it and return a new array. The remove function should remove the given book name from the array passed to it. Note, both functions should return an array and any new parameter should be added before the book name parameter. We'll start with the add. Okay? So this add function will take a list of books as an array, as a parameter, and instead of modifying the book list global variable, we will instead add the book to the list parameter and return that list. I want to see what happens. So console log book list. There's our book list with 4 books. I also want to console log what happens when we call add with book list, name of a book, name of a book. Okay, I got one. Docs for developers. It's a good book, by the way. Okay, so we're calling add with, we pass in the book list and we pass in the name of a new book. Let's see what happens. First, it console logs a book list. Then it console logs that not the same list of books. We'll see in a moment. A list of books with the first 4 that we know, and docs for developers at the end. Now let's see what happens when I console log book list again. After having added that book, you'll see, wait, return a new array. The add function should add the given book name to the end of the array and return a new array. Ah! Aha! The problem is that we're passing in that book list, but we still need to modify it. Sorry, we still need to make a copy. Let's say const new list equals. There we go. Now we're making a copy of that list of books. We push that new book onto that list, and then we return that new list. Let's see again. First, there's the original book list. Then there's the new list. And then the original book list remains unmodified. Let's do the same here. So we want to remove a book name from a list. First, we need to declare that list as a parameter. Then we need to make that copy of the list. We will get a new list. We will get an index. Then we will remove that book from the new list, and then we'll return the new list. Let's try it now with remove. And let's remove this one here on the electrodynamics of moving bodies. Now let's see what happens. First, we've got the original book list. Then we've got the new list with only 3 books. And then we've got the original book list unmodified. Let's run our tests. There we go. We do a little pat, and we move on. Now we're going to use the map method to extract data from an array. Map might be one of my favorite JavaScript concepts. So far, we've learned to use pure functions to avoid side effects in a program. Also, we've seen the value in having a function only depend on its input arguments. But this is only the beginning. So what we can do with using callbacks, let's see, is use them as first-class objects in JavaScript, which means they can be used like any other object. So let's start with some simple array functions, which are methods on the array object prototype. In this exercise, we are looking at array prototype map, or more simply, map. I will leave that as a question. CPU Cortex, I see your point. We'll get to there at the Q&A because I might disagree a little bit. So the map method iterates over each item in an array and returns a new array containing the results of calling the callback function on each element. It does this without mutating the original array. When a callback is used, it is passed 3 arguments. The first argument is the current element being processed. The second is the index of that element. And the third is the array upon which the map method was called. Let's take a look at this example here. We've got an array of users, each of which is an object with a name and an age. So here's what we can do. If we wanted to get all of the names from this array, we can call users.map and then give it a callback. This callback says, hey, for each user, return user.name. If we console log this, we will get John, Amy, and Campercat. So what we're doing is iterating, we're iterating over each user and returning user.name. Before we start messing around with this code, which is a lot of code, let's keep going. Let's go all the way down. Actually, I'm going to delete all of this code, if I may. And instead, what I'm going to do is just play around with my own. Take an array of 1, 2, 3. Let's use map to give us an array of each number doubled. Yeah? Const doubled equals r.map. Sorry, that's really annoying, and I'm going to turn off this iPad so that it doesn't bother us. Sorry, folks. Give me 1 sec. How do I do that? Now it's quiet. Sorry about that. Where were we? Right. We're going to call r.map, and now we need to pass in that callback. So we'll pass in an arrow function that returns num times 2. Like console log doubled. Let's have a look. So what this does is iterate, loop through the array, and call this function on it, on each object. Num returns num times 2. So first it does it for 1, which gives us 2. Then it does it for 2, which gives us 4. And then it does it for 3, which gives us 6. And we can do anything. For example, let's return a string. I am a number, and my value is, and then we'll put in num. So check it out. Now it returns a string, which says, I am a number and my value is num. Check it out. I am a number and my value is 1. I am a number and my value is 2. I am a number and my value is 3. Heck, we could return a Boolean. Let's say we want to have an array of Booleans for whether each number is even or odd. Num percent, where's my percent? 2 is equals to 0. So that will check if dividing by 2 gives us a remainder of 0. If the remainder is 0, you remember, then it's even. So this is actually called is even. So, well, for 1, it's false because 1 is not even. For 2, it's true because it is even. For 3, it's false because it's not even. What if I put in 4? And it'll be even again. What else could we do? Let's call it squares. So we'll do number squared for each of them. So num times num. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So we can do all. Let's do it to the power of 3. Wait, I'm sorry. Num times times? No way. Nah, that doesn't work, Carlos. I'm sorry. How about we do it cubed? Num times num times num. Let's see. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. Yeah. So we can do all of these things. Any function we want, we can pass into map, and it'll just call it for all of those. So what's our what's our exercise now? I'm just going to restore the code as it was before. The watch list array holds objects with information on several movies. Let's see, we got watch list with the movie Inception. We got a lot of data for it. Interstellar is the next movie. And we've got The Dark Knight. What else have we got? Batman Begins. This is looking like a list of Christopher Nolan films. Nope, I was wrong. Avatar. Okay, folks want to find out if we can do console log num times 3. Oh, right. Const num equals, I don't know, 5. Okay, thank you, CPU Cortex. That works. That's pretty cool. Did not know that was possible. Right, so we've got all those films. Use map on the watch list to assign a new array of objects to the ratings variable. Each movie in the new array should have only a title key with the name of the film and a rating key with the IMDb rating. The code in the editor currently uses a for loop to do this, so you should replace the loop functionality with your map expression. Let's take a look at what the code is doing. So we got our empty array of ratings, and for each film, we are pushing into ratings a new object with the title of that film and the rating of that film. And we want to replace this with a map. So let's do that. I'm going to comment this out and instead say const ratings equals, I already forgot, it's a watch list. Watch list.map. And for each film, we'll have a callback that returns a new object, film title. We need to put in the key. Film title and rating, which is film IMDb rating. And I am missing a semicolon somewhere. I forgot to close my object. Checked. Oh, I think it's getting confused because of this. So I'm just going to do it this way and return. There we go. So I'm mapping through it. And for each of them, I'm returning an object with the title and the rating. And that gives us Inception with a rating of 8.8, Interstellar with a rating of 8.6, Dark Knight with a rating of 9.0, Batman Begins with 8.3, and Avatar with 7.9. So there we go. We've now effectively replaced our for loop, just going to delete that, with a map. So that's nice. Let's see if FreeCodeCamp agrees with me. Run the tests. Yay! Pat ourselves on the back here. Pat, pat. Ooh, now this is interesting. As you've seen from applying array prototype map or simply map earlier, the map method returns an array of the same length as the one it was called on. It also doesn't alter the original array as long as its callback function doesn't. In other words, map is a pure function and its output depends solely on its inputs. Plus, it takes another function as its argument. You might learn a lot about the map method if you implement your own version of it. It's recommended that you use a for loop for each. So for our exercise, we're going to write our own version of map called myMap, which should behave exactly like map. You should not use the built-in map method. The array instance can be accessed in the myMap method using this. So let's see what we got. We've got an array called S, and then we're defining myMap on every array, which takes a callback. It defines a new array and it returns that new array. And then we've got new S is equals to s.mymap, and then it has a callback here, which takes each item and multiplies it by 2. Let's console log this. Now remember, this is the array itself, which is convenient. Because then what we can do, now we're going to do this with a for loop. So we want to, let me write out my pseudocode. Loop through this, call the function on each item, push to new array, the return value. That's pretty, and then we return new array. So for let member of this. So there we are going through each member of this. Let's console log just to make sure I'm doing the right member of each. Stop console logging this for a second. So we are console logging. We're iterating through each member of the array, which is good. Then we want to const result equals. We're going to call the callback and pass to it as a parameter member. I want to console log result and member. So when I call the callback on 23, it gives me 46. When I do it on 65, it gives me 130. When I do it 98, it gives me 196. When I do it on 5, it gives me 10. And if you forget what that callback is, we're calling it here, right? Return item times 2. So call the function on each item, push to new array the return value. So new array dot push result. Once that's done, I want to console log new s and see what we got. 46, 130, 196, and 10. And just to verify, yeah, that's each member times 2. So now we've seen how we do map. We loop through each member of the array. We call the callback on that member of the array, and then we push it to a new array, which we then return. Let's run our tests. Nice. Pat, pat. Let's keep going. Another similar function is called filter. Filter is similar to map. It calls a function on each element of the array and returns a new array containing only the element for which that function returns true. In other words, it filters the array based on the function passed to it. Like map, it does this without needing to modify the original array. Let's check out what's going on here. So we got an array of users like before, and now we want to check all of the users under 30. So we call users.filter, and it calls this function on each. If user.age is smaller than 30, then that gets returned to the new array. So the console would display the value for Amy, who's 20, and Campercat, who's 10, but not for John, who's 34. Good to know. I want to try this out myself. Const 1, 2, 3, 4. And whoops. Now let's filter out all evens. We're going to filter out all of the ones that are not even. Num. So num percent 2 is equals to 0. All of the ones that are not even will be filtered out. Let's console log all evens. It gives me 2 and 4. So it does it in 1. Is 1% 2 equals 0? No. So it gets filtered out. Is 2% 2 equals 0? Yes. So it gets left in. This is handy for iterating through lots of them and checking that the callback returns true. If it returns true, then it gets left inside. If we wanted to check if it's divisible by 3, for example, 1 is not divisible by 3, 2 is not, 3 is, and 4 is not. We can do it with comparisons. Num is bigger than 2. That just gives us 3 and 4. What about less than 2? That just gives me 1. So with that said, let's see what we got here. We got our watch list. Okay, the same movies as before. Interstellar, Dark Knight, Batman Begins, and Avatar. So let's see what we got. Use a combination of filter and map on watchlist to assign a new array of objects with only title and rating keys. The new array should only include objects where IMDb rating is greater than or equals to 8.0. Note that the rating values are saved as strings in the object, so you may need to convert them into numbers to perform mathematical operations on them. Okay, that's a lot. So I'm going to break this down into 3 parts. First, get all of the ones for which IMDb rating is bigger than 8, and then turn them into objects with title and rating. Filter out movies less than 8 rating. Convert to title and rating objects. So we'll do that first. I'm just going to remove this filtered list for now. Const filtered films equals watch list dot filter. I'm just going to make this wider so we have more space. And we'll have film. Make this a multi-line one. So what was that caveat it gave us? Note that the rating values are saved as strings in the object. So const rating as number. Remember last time we explored parse int? Let's do that. Parse int film IMDb rating. Let's console log that rating as number. Wait, not parse int, should be number. You know why? Because int, notice what happened. We got 8.8, 8.6, etc., etc. If I do it as parse int, it turns them all into integers and removes their decimal points, which is not what we want. So if we do it with number, with a capital N, whew, okay, then we save our decimal points. Cool. So we want to return whether rating as number is bigger than 8.0, bigger than or equals, right? Greater than or equal to 8.0, 8.0. So if I console log filtered films, that gives us inception. It gives us, because it's got 8.8, Interstellar, which has 8.6, Dark Knight, which has 9.0, Batman Begins, which has 8.3, but not Avatar, which, if I remember correctly, had a rating of 7.9. See? Yeah. So that's the filtering done. Now we need to convert them to title and rating objects, which we've done before. Const filtered list equals filtered films.map. We've done this before. Film, return that object, rating film. Oh yeah, IMDb rating. And the title, which is film title. And there we go. Now we've got all of the filtered films that are above 8.0 and converted to this new format. Let's run our tests. And there we go. We do a little pat. I know it's past the hour. I just want to do a couple more of these to make sure we're off on the right track. If you have to go, I totally understand. Don't worry, this is going to be recorded. We'll do some Q&A afterwards. You might learn a lot about the filter method if we implement our own version of it. Okay, so this is going to be like before. We've got, let's see, write your own prototype my filter, which should behave exactly like filter. You should not use the built-in filter method. The array instance can be accessed using this. Okay, we've done this before. So we've got our S, which is 23, 65, 98, and 5. We're defining a new my filter, which takes a callback, defines a new array, returns a new array. And here we're calling s.myFilter with a callback that returns what that is filtered out if that item is not divided by 2 is not remainder 1. So loop through this. If the callback returns true, add member to new array. Right? Should be as simple as that. Let's try it out. For let member of this if callback with member, and we add the member to the array. New array.push member. That should be it. Let's console log new s. So 23 is odd, 65 is odd, 5 is odd, but 98 is even. If I change this to 0, it's just 98. How cool is that? We've implemented our own filter function. Let's run our tests. And yes, pat. Let's keep going. Return part of an array using the slice method. So the slice method returns a copy of certain elements of an array. It can take 2 arguments. The first gives an index of where to begin the slice, and the second is the index for where to end the slice, and it's non-inclusive. We've done this before. If we call slice on cat, dog, tiger, zebra with 1 and 3, that'll give us dog and tiger. Use slice in the method slice array to return part of an array given the provided begin slice and end slice indices. The function should return an array. So what have we got? We got an input of animals, and we want to call slice array with input anim 1 and 3. So we'll just return anim.slice, begin slice, end slice. That should give us dog and tiger like before. Dog and tiger. Let's run our tests. Cool. We've used slice before, so we'll pat and keep going. Remove elements from an array using slice instead of splice. Now, we know the difference between slice and splice. Splice, if we call it on cities, Chicago, Delhi, Islamabad, London, and Berlin, if we return one object at index 3, that'll modify cities. Yeah. Here, splice returns the string London and deletes it from the cities array, which will have the value Chicago, Delhi, Islamabad, and Berlin, removing London. As we saw in the last challenge, however, the slice method does not modify the original array, but returns a new one, which can be saved into a variable. So we will rewrite the function non-mutating splice by using slice instead of splice. It should limit the provided cities array to a length of 3 and return a new array with only the first 3 items. Do not mutate the original array provided to the function. Console log non-mutate input cities. So we got Chicago, Delhi, Islamabad, London, and Berlin, which modifies the input cities by splicing out the first 3. But as we know, we want to instead return a new array, because if we console log this, it's only going to give us the ones that were removed. See? It's showing us London and Berlin, and return a new array with only the first 3 cities. So non-mutating splice should actually, it should limit the provided cities array to a length of 3 and return a new array with only the first 3 items. So if I change this to slice, let's see what happens. Now it's no longer being modified. However, it's still returning the last, everything after the 3rd index, which, as we know, is not correct. We wanted to return the first 3 members. So we'll go from 0 until index 3. There it is. Chicago, Delhi, and Islamabad. That's it. Let's run our tests. There we go. Pat. I know we're 10 minutes past the top of the hour. Kiki, I'm sorry. If you need to go, please, totally fine. I need to do a couple more. This is a long one, and I want to make sure that we understand functional programming as much as possible. So let's see what we got. Concatenation means joining items from end to end. The concat method for both strings and arrays that work on the same array. For arrays, the method is called on one, then another array is provided to the argument to concat. So what's going on? If we call concat on 1, 2, 3 and pass with the argument of 4, 5, 6, we get a new array of 1, 2, 3, 4, 5, 6. So use the concat method in the non-mutating concat function to concatenate attached to the end of original. The function should return the concatenated array. Return original.concat. Let's see what that does. It takes 1, 2, 3 as first and 4 and 5 as second, and it returns the original with the attachment concatenated. If we console log that, that should give us 1, 2, 3, 4, 5, and most importantly, should not modify either of the arrays. There it is, unmodified, unmodified. Let's run our tests. Looks good. Pat, pat. We'll keep going. Add elements to the end of an array using concat instead of push. So here's the thing. You can push several elements to an array, right? Let's take this code and give it a try. Going to take all of this away. Console log R. Here's the thing. 1, 2, 3, 4, 5, 6. We have an array. We call push on that array, and we console log that array. The array has been modified, right? This is good. But what if we wanted to do this functionally? That is, we don't modify the original array. See what we got. A non-mutating push. Do original and new item. So we want to return original.push new item. Let's console log. We got first, we got second, we got non-mutating push. Let's console log all of these. Console log first, comma, second. So a couple of things are going on here. First, push returns the new length of the array. That's the 4. Next, first has now had a value of 1, 2, 3, and the array 4 and 5. It has been modified. The second remains unmodified. But what we want to do is have the modified value of 1, 2, 3, 4, 5, 6. Wait, where's the 6? We'll get to that. We'll get to that. Oh, sorry. I was reading this one. 1, 2, 3, 4, 5, 6. Change the non-mutating push function so it uses concat to merge new item to the end of the original without mutating original or the new item arrays. So instead of using push, we're going to use original concat new item. Now, 1, 2, 3, 4, 5, and now first and second are unmodified. Let's run our tests. Yeah, there we go. Pat, pat. Let's keep going. And this is the one I wanted to get one before leaving you all with homework. Let's talk about reduce. Reduce is the most general of all array operations in JavaScript. So the reduce method allows for more general forms of array processing, and it's possible to show that both filter and map can be derived as special applications of reduce. The reduce method iterates over each item in an array and returns a single value. This is achieved via a callback function that is called on each iteration. So it sounds similar. I'm just going to delete all of our code and mess around with reduce. It sounds similar to what we've been doing so far. But the callback function accepts 4 arguments. The first argument is known as the accumulator, which gets assigned the return value of the callback function from the previous iteration. The second is the current element being processed. The third is the index of that element, and the fourth is the array upon which reduce is called. Akachuku, I'm saving your question. I don't really understand when things are being mutated. Could you please expand on that question? Maybe give me the name of an example we can come back to, and during Q&A, we'll solve that. Okay? So please expand on that question. What do you mean you don't understand when things are being mutated? And we'll do that during the Q&A. In addition to the callback function, reduce has an additional parameter, which is the initial value for the accumulator. If this second parameter is not used, then the first iteration is skipped, and the second iteration gets passed as the first element of the array. The second iteration gets passed the first element of the array as the accumulator. We'll get there. See below for an example. Yeah, we have an example. Using reduce to return the sum of all the user's ages. For simplicity, the example only uses the first and second arguments. I'm going to take this code and have a look. Okay. So we have an array of users, which we've seen before. To get the sum of ages, we are calling users.reduce. This takes two parameters. The first is the callback, which we'll get to in a second. And the second parameter is the initial value. So the initial value of this sum is 0. Makes sense. In this callback, we're passing two parameters. One is the sum, that is the accumulator, what the sum is so far, and the user. And we are returning sum plus user.age. Let's expand this into a more full function so that we can examine how it runs. Let's console log sum and user.age. So in the first iteration, the sum is 0. That's where the accumulator comes in, right? The initial value of the sum will be 0, and we return sum, which is 0, plus user.age. In the next iteration, sum will be 34, because it is the return value of the previous iteration. So sum is 34, user.age is 20, so we return 34 plus 20. In the next iteration, the sum so far is 54, and the user age is 10. We return 54 plus 10, which gives us 64. And Carlos is asking the question, what if we remove the 0? Because if you remember in the instructions, if this second parameter is not used, then the first iteration is skipped, and the second iteration gets past the first element of the array as the accumulator. Let's see what that means. I'm going to remove this. Now let's see what happens. Sum in the first iteration is the object of the first member. Right? So what happens when we add 20 to name John age 34? We get a string object 20, to which we add a 10, which returns us an object object 20 10. So it's just building a big string. Let's try it with something different. Let's try it instead with an array. 1, 2, 3. Let's say we wanted to have a const sum, which is equals to r.reduce. Now, our callback takes two parameters, sum and the member itself. And our accumulator starts at 0. Let's console log sum and num. will return sum plus num. Sum plus num. Am I doing this right? I think so. Yeah. Oh yeah, we still need to console log the sum at the end. So, okay. At first, the sum is 0 and the num is 1. That's the first one. 0 plus 1 is 1. So sum next time will be 1 and num will be 2. 1 plus 2 is 3. So the next iteration and the final iteration, sum is 3, num is 3. 3 plus 3 gives us 6. Let's go back to Carlos's thing again. What happens if we remove the 0? That starts us off. Now we do 2 iterations. It skips the first one and assigns the first member of the array to be sum at the beginning. So at the beginning, sum is 1, num is 2. 1 plus 2 is 2. 1 plus 2 is 3. 3 plus 3 is 6. Okay? So that's reduce. I recommend highly messing around with this. Let's reset our code and see what the exercise wants. So we've got our watch list. Holds an array of objects with information on several movies. It's the same movies as before, nothing we haven't seen before. The Dark Knight, Batman Begins, and Avatar. Cool, cool, cool. Use reduce to find the average IMDb rating of the movies directed by Christopher Nolan. Cool. Recall from previous challenges how to filter data and map over it to get what you need. You may need to create other variables and return the average rating in the getRating function. Note that the rating values are saved as the strings, as saved as strings, so we need to convert them to numbers. Okay. Cool. So how about first filter out Nolan films. Then get all ratings. Then sum all ratings. Then return sum divided by number of Nolan films. That's how we get the average. Cool. This we know how to do. Const Nolan films. Oh, Mitch, thank you. Convert ratings to numbers. Yes. As numbers. Thank you, Mitch. My bad. So Nolan films will be equals watch list dot filter. Now we want to only have the ones that are directed by Christopher Nolan. I need to find out how to, what's the property called? Director. So film director is 3 equals Christopher Nolan. I'm just going to copy that. So film director is 3 equals to Christopher Nolan. Console log Nolan films. We got Inception, we got Interstellar, we got Dark Knight, and Batman Begins, and not Avatar because Avatar was directed by James Cameron. That's the first part done. Now we'll get all the ratings as numbers. So const ratings as numbers equals Nolan films dot map. And we'll return a number as the film's IMDb rating. Console log ratings as numbers. There we go. 8.8, 8.6, 9, and 8.3. Now we need to sum all of the ratings. Const sum of ratings equals ratings as numbers dot reduce. And that needs a callback with two parameters. One is the sum so far and the rating. That will return sum plus rating. And we'll start out as 0. Sum of ratings, 34.7. I would assume that's correct. I'm not here to do math. Then we'll return that sum divided by the number of Nolan films. Return sum divided by Nolan films dot length. Sum of ratings. My bad. So the average is 8.675. That's a good average, I would say. Oh, right. I didn't do this right. I should have assigned this to average rating. Assign sum to average rating. There we go. 8.675. Yash says, reduce reminds me of a Fibonacci spiral. It kind of is. It kind of is. I like that comparison. Let's run our tests. Phew. All right. Pat. Oh, Mitch asking the good questions. If you remove the 0 in the reduce function, does it give the same result? Let's find out. It should give us 8.675. Now, why did that work? That's because if we don't pass in an initial value, then the first iteration will be put into sum. So it starts out with whatever the rating of inception is, which is 8.8. Thanks for asking, Mitch. That's a great question. Yep. Still good. Pat. I think we can stop here. I will leave you with higher order functions, map, filter, or reduce to solve a complex problem. So the rest is left as homework. Oh gosh, I thought I'd done more. So I'm leaving you a lot of homework. Hope that's okay. So as homework, your task is to finish the rest of functional programming. I wish I could keep going, but I do have to respect people's time. Once again, as homework, finish functional programming. Tomorrow, we will start with intermediate algorithm scripting. Now, folks, this is a lot. Don't stress about finishing it by tomorrow. We might be able to come back and solve some of these during Q&A. Speaking of which, we have a question that I've been wanting to answer from Akatsuku, that you don't really understand when things are being mutated, saying splice mutates an array while slice does not. And I'll show you what that means with an example. Let me just delete this. Okay, so we got an array with some numbers, 9, 56, 47, 32. If we call r.splice, wait. Console log r.splice, let's say we want to splice out everything starting at index 2. Console log r. So if we splice out everything starting at 2, it gives us 47 and 32. Yeah? R.splice with a parameter 2 splices out of the array everything starting at 2. If we console log r after that, we'll see that array, that r, no longer has 47 and 32. Splice Splice has mutated R. But what if we wanted to do the same thing now, but with slice? We wanted to remove everything starting at 2. We will use slice instead. Now look at what happens. We have 47 and 32. We're slicing out, we're getting a slice of everything starting at index 2, and R is unmodified. It means that splice mutates the array and slice does not. I hope that's clear. Please, 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 if it's not, come chase me here in the chat. Hope that's helpful. I want to go back to what CPU Cortex was saying. Copying a list is a costly operation. Now, I don't want to get too deep into it, but do you remember which one that was, CPU Cortex? Let's see. Understand the hazards. Was it avoid mutations? No. Programming terminology? No, it was the book list. It was the book list. Where's our book list? Where is our book list? Pass argument. Refactor global variables. Right. So we have a couple of ways of doing this now that we've learned some more. Remember, we had our book list and we wanted to add a book name. So one thing we did was add it to the end. Const new list equals, oh wait, first we need to have the list itself. We made a copy of that list and returned that new list. You're saying copying a list is a costly operation. Now, I would argue that pushing needs to loop through the array to find out what the index at the end is, and then add it to the end. This is equally costly and has a complexity of the end of the array. Now, not to get too much into complexity in terms of big O notation, but both this operation and this operation, in my experience, in my understanding, have the same complexity, making it not worse to do. However, now that we know concat, we could do it like that. For example, what if we instead returned list.concat, an array that just has the new book name? Now we're concatenating this array, which has the book, and it's giving us a new array. Console log book list. Console log book add list. Book hello. We're going to call our new book hello. I can't spell. Console log the original book list again. Now we have the original book list, the book list with the new book added, and the original book list has not been modified. This probably is equally complex, equally costly, but it's shorter code, which is nice. Thank you for asking that. That's a good question. When using filter or map functions, the return array seems to contain leading and trailing spaces. Any way to get rid of to get the same without those spaces? Let's have a look, Pramod. So R equals 1, 2, 3. Const only odd r.filter. Only odd r.filter Actually, only more than 1. Is bigger than 1. Console log are only more than 1. Ramón is saying when using filter or map functions, the return array seems to contain leading and trailing spaces. Pramod, I wouldn't get thrown off by what FreeCodeCamp, the console, is doing here. There are leading and trailing spaces, but this is just the way that arrays are displayed in the console. So it's not, there's no leading or trailing spaces in the array. Because if you notice, let's say these are strings. Yeah. Okay. Bear with me. Let's say we got 3 strings. Hi, hello, and hola. Okay, 3 different ways of saying hello. And let's say long greetings. It'll be an array filtering out all of the greetings that are longer than 2. Greeting.length is bigger than 2. Console log long greetings. So you notice the strings don't have leading and trailing spaces. But these spaces here are added by the console just to make the arrays nicer to read for us humans. But in truth, the array itself does not have those spaces. Okay? Hope that helps. Triple M says, with regards to the exercise on my map, could you please re-explain why we had to write callback member in the for loop? That's a great question. Where was that? Map. Mutations. Use a map method. Implement map on a prototype. Cool. So we are implementing our own version of map where we get a for loop. Let member of this is the array, and we would call what does this give us? What do we want to do? Oh yeah, new array dot push, calling the callback on the member. And let's console log s. That's each member multiplied by 2. So what we're doing, so the callback itself, let's console log the callback. The callback is a function which gets passed as a parameter to my map. This is the callback that we're passing. It is a function that takes an item and returns that item times 2. So what we're doing here is looping through each member of the array and calling that callback on it. Let's console log callback member. I'll do you one better. We'll console a callback and the member itself. So we loop through each number. There we go, 23, 65, 98, and 5. And this is the return value of calling this callback, which you remember is this function here that we passed as a parameter, with member as a parameter. So what happens? We say, hey, callback, process this parameter. Let's scroll. Oh, I'll tell you what. Yeah. Let's visualize it. Yes, I'm excited. Whoops, what am I doing? There we go. Nice. All right, so we start with our S. In fact, there's our S array. We add that function to the array prototype. We define this callback. And then so this, check it out. Oh, this visualizer is so good. Thank you, Sil. This is the array. Callback is this function. How cool is that? So what happens? Okay. We define a new array. We console log the callback. Then we start looping. The member is 23. And look, now it's calling the callback and saying, okay, item is 23. Let's return it times 2, which gives us 46. That's done. Let's push calling callback on member, which calls it again because I called it twice here. So we're saying, okay, call this function, pass to it 23, return item, which is 23 times 2, which gives us 46. Now we push that onto new array. So now new array has 46. This visualizer is so good, y'all. Oh, this is so good. Okay. For the next one, the member is 65. See here. Call that with 65, gives us 130. Call it again, gives us 130. We push that to the new array. Bam, there it is. Next, for 98, we call it 98 with the callback, gives us 196. We call it again because I called it twice here in the code. 98 gives us 196. We push that to the new array. Bam. Next one. 5. 5 times 2 is 10. We call it again because I wrote it twice in the code. 5 times 2 is 10. Push that to the new array. That gives us 10. We return that new array, and we're done. How cool is that? We're done. Hope that helps. That was a really good one. Do we got any more questions? I love all the experiments you're trying here, Carlos. Let's see what we got. Const r equals 1 undefined and null. Oh, that is interesting. So you're defining, well, let's play around with this. We've got some time. In the meantime, folks, if you got any more questions, hit me up. Const r equals 1 undefined, not a number, null, 2, comma, 3, 4. I want to console log r. We got 1 undefined, not a number, null, 2, nothing, 3, and 4. Then your console log the filtering of n if n. So r.filter n. Now what's going on here? Remember, filter will add it to the new array if the return value is true or if it's truthy. So what's going on? 1 is truthy. Undefined is falsy. If you remember, truthiness and falsiness refer to the previous sections. Undefined is falsy. Not a number is falsy. Null is falsy. 2 is truthy. These empty values are falsy. 3 is truthy. And 4 is truthy. It's a good one. Well, I don't think we have any more questions. As Michael says, it uses the truthy values of all the elements. Exactly. Don't think we have any more questions. So, again, homework is to finish functional programming. Okay? Folks, remember, you are not alone. Use the forum. Use the Discord. If you get stuck, ask questions. If you know the answers, please answer them. Like, I got to go into my day job now, so I'm not going to be able to answer all the questions right away. But all of you who are able to, it's kind of a secret ticket to learning because explaining things helps you materialize them in your head as well. So I highly recommend that. I love functional programming. This is one of my favorite lessons. It's so mind-bending. It's really fun. Don't worry if not everything's clicking right away. Remember, there's time, there's no deadlines. We can get this certification anytime after this boot camp is done. So keep going, don't give up, encourage each other, learn together. Tomorrow, we will start with intermediate algorithm scripting. And until then, get some rest too, folks. You're doing great. Enjoy the rest of your day or the rest of your evening, and see you tomorrow. Bye now.